Imagine, if you will, a universe unconstrained by the speed of light. A place where the vast cosmic distances shrink under the might of human ingenuity and the stars are but a stone's throw away. This is the tantalizing world of faster-than-light travel, a concept that has enchanted scientists and science fiction enthusiasts alike for generations. In the heart of this concept lies a universal constant, the speed of light. Approximately 300,000 kilometers per second, this cosmic speed limit is the cornerstone of Albert Einstein's theory of special relativity. According to this groundbreaking theory, as an object accelerates towards the speed of light, its mass increases exponentially. Now, picture a car accelerating on a highway. The faster it goes, the more fuel it burns. Similarly, as an object approaches the speed of light, it requires more and more energy. But here's the catch: when it reaches the speed of light, its mass becomes infinite, and so does its energy requirement. This notion, my friends, presents a seemingly unbeatable speed limit to the cosmos. The implications of this for faster-than-light travel are profound. It suggests that anything with mass, be it a spaceship or a speck of dust, would require infinite energy to achieve light speed, let alone surpass it. This is akin to asking a car to run on an infinite amount of fuel, a proposition that seems, at least with our current understanding, utterly impossible. And so we find ourselves facing a cosmic conundrum. On one hand, we dream of traversing the cosmos at speeds faster than light, of exploring distant stars and galaxies within a human lifespan. On the other hand, we are seemingly held at bay by the laws of physics themselves, bound by the speed limit imposed by light. Thus, according to Einstein, breaking the speed of light barrier seems an insurmountable challenge. However, the human imagination knows no bounds, and one solution might lie in warping space itself. This is where the concept of the Alcubierre Drive comes into play. Conceived by physicist Miguel Alcubierre in 1994, it's a theoretical solution that could make faster-than-light travel a reality by bending the rules of space and time. The Alcubierre Drive does not propose to propel a spacecraft at speeds faster than light. Instead, it suggests a way to manipulate the very fabric of space-time. Imagine a spacecraft sitting within a bubble of normal space-time. This warp bubble would then contract space in front of it while expanding space behind it. It's a bit like moving a rug while standing on it. The rug moves, but you stay still. In this scenario, the spacecraft would remain stationary within the bubble while space-time itself moves. The beauty of this approach is that it doesn't violate Einstein's theory of special relativity. The ship isn't moving faster than light within its local frame of reference. Instead, it's space-time that's doing the moving, so you might be wondering, how does one create a warp bubble? Well, that's where things get tricky. The Alcubierre Drive requires something called exotic matter, with negative energy density to create the warp bubble. This exotic matter has yet to be discovered and remains purely theoretical at this point. The Alcubierre Drive presents an interesting paradox. On one hand, it's an idea that could potentially break the cosmic speed limit set by light, allowing us to venture to far-off galaxies in a blink of an eye. On the other hand, it requires resources and technology that are currently beyond our reach. In essence, the Alcubierre Drive opens up a world of possibilities, a universe where the vast distances between stars and galaxies could be traversed within a human lifetime. It's a concept that pushes the boundaries of our understanding and inspires us to dream big. An elegant idea, yet one that requires resources we've yet to discover. But what if we could bypass the speed of light altogether? This question leads us into the realm of quantum mechanics, where the rules of the game change, and concepts like entanglement and tunneling come into play. Let's start with quantum entanglement. This is a phenomenon where pairs or groups of particles interact in ways such that the state of each particle cannot be described independently of the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein once put it, hints at the possibility of instant communication across vast distances. Imagine sending a message to an astronaut on Mars, and they receive it the instant you hit send, with no lag time. This could revolutionize not just space travel, but communication as we know it. Next, we delve into quantum tunneling. This is a quantum mechanical phenomenon where particles have a certain probability to tunnel through potential barriers, even those that classical mechanics would deem insurmountable. This suggests that particles can hop through these barriers faster than light. If applied to a larger scale, this could potentially allow for instantaneous travel across the universe. Picture yourself stepping into a tunnel in New York and stepping out from the other end in Tokyo, all in the blink of an eye. Yet, as tantalizing as these concepts are, it's important to remember that we're still in the realm of theoretical physics. Quantum entanglement and tunneling, while fascinating, do not currently offer a practical method for transporting anything larger than a particle. And that's the crux of the matter. We're dealing with the world of the incredibly tiny, where rules are vastly different from our everyday world. The challenge lies in bridging the gap between quantum mechanics and the macroscopic world we live in. Intriguing theories, yet they currently remain just that, theories. But who knows what the future might hold? After all, the only limit to human ingenuity is the extent of our imagination. In the vast cosmic landscape, could there be shortcuts waiting to be discovered? Contemplate the idea of hyperspace, a concept often found in the pages of science fiction. Picture a higher dimensional realm where the constraints of our familiar physics don't apply, where the speed of light no longer serves as the ultimate limit. In this extraordinary dimension, faster than light speeds could, in theory, be possible. This isn't to say we'd be defying the laws of physics, but rather stepping outside of them, into a domain where new rules apply. Now let's shift our attention to something a touch more tangible: wormholes. These are theoretical bridges, shortcuts if you will, connecting 2 points in space-time. Imagine folding a piece of paper in half so that 2 points touch. That's essentially what a wormhole does to the fabric of space-time, bringing distant locations into immediate proximity. In essence, a journey through a wormhole could be instantaneous, regardless of the actual distance between the start and end points. The idea of these cosmic shortcuts is tantalizing, promising a universe where the stars are within our reach, where intergalactic travel could become an everyday reality. Yet, these cosmic shortcuts come with their own set of challenges. But as they say, every problem is a disguised opportunity, and perhaps these challenges will drive us further into the realms of discovery and innovation. The path to faster-than-light travel is strewn with obstacles, both theoretical and practical. The Alcubierre Drive, for instance, hinges on the existence of exotic matter with negative energy density, a phenomena yet to be observed in our universe. Quantum entanglement and tunneling, though fascinating, do not presently provide a feasible method for transporting anything larger than microscopic particles. And as for wormholes, if they do indeed exist, their inherent instability presents a formidable challenge, requiring negative energy to maintain. But let's indulge in a moment of speculation. What if these obstacles were surmountable? The future of FTL travel could reshape the very fabric of our existence. Interstellar exploration, once the realm of science fiction, could become as commonplace as a transatlantic flight. Imagine, if you will, a future where voyages to the nearest stars are measured in hours, not millennia. And what of the potential for first contact? With the galaxy as our playground, the chance of encountering extraterrestrial civilizations would be exponentially increased. The resources of the cosmos, from alien minerals to exotic energy sources, could be within our grasp. The future of FTL travel remains uncertain, but the human spirit continues to dream and explore.